So today in class, you worked on an in-class exercise on the following problem. I told you I would come in and I would create a video going over the solutions to those problems that you went through. So looking at the following, we have f of x is equal to the square root of x. And then outside of the square root of x, we have minus 3. And you're answering the following question. So first of all, we want to find f of 9. And so all you're doing is you're going up into your equation, f of x. And wherever we see an x in our equation, we're replacing that with a 9. And so f of 9 here we have, this is equal to the square root of x. But instead of writing x, we're going to replace that with a 9 minus 3. So square root of 9 here gives us back 3. 3 minus 3 is equal to 0. So the following problem, the next one says find the limit as x approaches 9 of the following rational expression, the square root of x minus 3 all over 9 minus x. And so first thing that you want to try when you're looking at a limit is direct substitution. But if we do direct substitution here and plug in 9 wherever we see an x, we get the square root of 9, which is 3 minus 3 in the numerator, which gives us back 0, divided by 9 minus 9, which also gives us 0. So we talked about getting, when we were taking limits, getting the form 0 over 0, and that was an indeterminate form, and it didn't tell us anything about the limit and where the graph was, what y value the graph was approaching as x approached 9. So we had to go back in here and we had to manipulate this limit. And so if we had a square root in there, the trick was to multiply by the conjugate. So changing the sign in between the radical and our number there. And so that would be the square root of x, in our case, plus 3, changing the sign in between. And we can't just multiply the numerator by that to rationalize the numerator. We want to multiply it by this fancy one. So the whole point was that we were creating a difference of two factors, which were difference of squares, if we multiplied those out. So if we distributed that out, we would get the square root of x quantity squared minus 3 quantity squared all over. So the piece that was not multiplying by the conjugate, let's just keep it there. Sorry, for some reason my pen on here in this program is not writing the best. It's kind of dragging, but hopefully you can see in that you're understanding. So anyways, so squaring the square root of x, we get x minus 3 quantity squared, which is 9. So I have x minus 9 all over. I noticed that down here, this 9 minus x is almost identical to my factor of x minus 9. So here, so we can manipulate these factors to be the same. Let's factor out a -1 from this 9 minus x. And if I do that, I would get back -9 plus x, or I can rewrite it in the order x minus 9. All over the square root of x plus 3. F factor. So I should be bringing down this limit until I go in and place in 9 wherever I see the x. So canceling like factors. We're almost there. We're going to take the limit as x approaches 9. So in the numerator, I'm left with a 1 all over -1. So I'm going to pull that negative out front here. Square root of x plus 3. So if I go in now and plug in 9 wherever I see an x, I'm not going to get an indeterminate form anymore. And we will be able to evaluate this limit as x is approaching 9. So we are going to get back here -1 all over the square root of 9 plus 3. So this is equal to -1 over, well, square root of 9 is 3. 3 plus 3 gives us 6. So we have -1 over 6. So the next problem you had was looking at finding the derivative of f of x at x equals 9. Just pull down f of x really quickly. So we have it in front of us. So when we're looking at the derivative of a function, right now we're using the formal definition. So no shortcuts here, not yet. We're looking at the limit as h approaches 0 of f of a plus h minus f of a all over h. And this is equal to the derivative of our function f of x when x was equal to a. So in our case, we're looking at when x is equal to 9. So in our case, a is equal to 9. So let's go back in here in this finding the derivative f prime of 9. That's how we would write that. We're looking at the limit as h goes to 0 of f of 9 plus h minus f of 9 all over h. So let's go back in here and let's plug in and evaluate f of 9 plus h. And so that's telling me I'm going into my function f of x. And wherever I see an x, I'm replacing that with a 9 plus h. So this is equal to the square root of 9 plus h minus 3. There's nothing I can do there to simplify. So that piece right here is this piece right here. So let's bring down our limit as h approaches 0 of f of 9 plus h, which we just found to be the square root of 9 plus h minus 3 minus, now we need to evaluate and figure out what f of 9 is. But that was the first part of this in-class exercise. We found f of 9 up here was 0. And so this would be minus 0 all over h. The problem in it is, again, when we go and we evaluate this limit here as h approaches 0, we're going to get 0 over 0, that indeterminate form. And so we need to go back and manipulate this. Again, this has square roots. And so a way to manipulate that so that we don't get that indeterminate form of 0 over 0, we're going to multiply by that fancy one. And that fancy one in this case is the conjugate of the square root of 9 plus h and then minus 3. So the conjugate there is the square root of 9 plus h. Change the sign in between those terms, so plus 3. So whatever we do to the numerator, we got to do the denominator, bringing down our limit as h goes to 0. We have the square root of 9 plus h minus 3. Well, multiplying that by the fancy one, that is going to square this first term. and square the second term. All over h times the factor square root of 9 plus h, and then outside plus 3. So squaring the square root, that cancels the radical, and it leaves us what's underneath the radical, which is called the radicand. And that's going to be 9 plus h minus 3 squared, which is 9, all over h times the square root of 9 plus h plus 3. So if you do everything correctly, things should start to cancel out, and we should be left with a factor of h both in the numerator and denominator. And if you look at this, we have 9 plus h minus 9. The 9s cancel with one another, leaving us with just h in the numerator. So the limit as h approaches 0 of h, all divided by h times the factor of the square root of 9 plus h. Outside the radical is a plus 3. Like I said, the h's cancel. So we're left here with the limit as h is approaching 0 of 1 all over the square root of 9 plus h, outside the radicals plus 3. So let's go back in and do our direct substitution. And if everything goes nicely, we should not have an indeterminate form anymore. So we have 1 all over the square root of 9 plus 0, and then plus 3 outside the radical. So this gives us 1 all over the square root of 9, which is 3, plus this 3, which is equal to 1 all over 6. So this is the derivative of our function of 9, our function at x equals 9. So one more piece to this in-class exercise was the following. Find the equation of the tangent line at x equals 9. So when we're trying to find the equation of the tangent line, we need to know what the slope is, in this case, of our function at x equals 9. Well, we just did that above when we found that derivative of f of x at 9. So we know what the slope is at x equals 9. We know that the slope of our function is equal to 1/6. So we need two things when we're trying to find the equation of line. We need a slope, which we have here, 1/6, and we need a point. And that point is going to be x equals 9. And we wanted to figure out what f of 9 is, which was the first part of the exercise, which we found was 0. So equation of line, two ways we can approach this. In my class, we tend to use y equals mx plus b. Plug in the values for our point, our x and our y value. Our x value is 9, our y value is 0, and our slope is 1/6. So if I do that, y is 0 equals to my slope 1/6 times x, which is 9, plus b. And if I solve for b now, then I know what my equation of my tangent line is, because I can go back into y equals mx plus b and just plug in my slope and my b value. We like to reduce our fractions. We have 1/6 times 9. I notice that both 6 and 9 are divisible by 3. So I can reduce this as 0 is equal to 3/2 plus b. So getting b by itself, I need to isolate b on one side of the equation, get everything else on the other side of the equation. So we're subtracting 3/2 on both sides. We get -3/2 is equal to b. So our y-intercept is -3/6 of the equation of the tangent line, and our slope is 1/6. So we know that the equation of the tangent line is y is equal to 1/6 x minus 3/2. Okay, so hopefully that was helpful. And you understand what you didn't get this afternoon when you were doing your in-class exercise. If you're not in my class and you're watching this video, hopefully this was helpful for you too.